And now I'll turn it over to Michele Casey, Senior Director of Product Management. Michele?
Thank you, Terry. So welcome, everyone. Thank you for taking time out of your busy schedules, especially on this holiday week for those in the US, to join us to learn a little bit more about our Oracle Linux Cloud Native Environment solution. I'm joined today by Daniel Krasinski, who is a principal engineer from our software development team, and as well as Daniel, who will be doing a demo and presenting with me today. We also have a couple other members of our development team, Felix and Vikas, who will be here and available to answer your questions. Now, I'm going to go ahead and move to the safe harbor statement, which I'm sure most of you have seen at some point in time, but I always like to give people just a moment to revisit the terms. We won't be talking too much about roadmap in today's session, but I think it's important that people understand anything that we say is, just a general outline. All right, so let me talk, before I get started, let me just set up a couple things. So, what we're going to cover today is the Oracle Linux Cloud Native Environment is the framework that we've been building over the past year. And I understand that there may be varying degrees of experience or exposure to the emerging trends around DevOps, so whether that be Docker or Builda or Kubernetes or any number of the given projects. Our focus today is to walk you through what the Oracle Linux Cloud Native Environment Framework is and how it interacts with all of these different components. We won't have time to go into detail on specific container technologies as an example, or in depth on different features within Kubernetes itself. However, I will include as part of the slides that will be distributed to everyone participating, some links to training that our training team has developed that will go into more details for some of those things if there is an interest from anybody participating today. In addition, I also just want to mention that we do have people who will be monitoring the chat window if you want to post your chat questions to the window. And we will also have some natural pauses within the demo timeframe where we can answer questions live with Daniel and the development team. So I just wanted to let you know if you can hold your questions or post them in the chat. And then when we get to some of these pauses within the presentation itself, we will review some of those questions and we can discuss those as we're waiting for certain processes to complete. So again, we're really excited today to present this to this team. We actually did this presentation at Open World this year, and it was actually, I think, one of the ACE participants who was in one of our sessions who asked if we could potentially bring this to the broader audience of the ACE and the ambassadors. And so with Terry and Jennifer's help, we were able to do that. So again, what we want to talk about today is this integrated framework that we've been developing over the last year for managing not just Kubernetes, but other core components that feed that ecosystem, that life cycle for managing your next generation applications, which are based in containers. And so for today, what you're going to see is we'll talk a little bit about what the framework is, and then we'll show you a little bit how it works. I think Daniel's going to go through a setup for you and really kind of walk you through how the different components fit together. And really the importance of the framework, one of the things that is most frustrating, I think, for users who are coming into this world or into this new environment is there's a lot of information, there's a lot of different components, and it's really difficult sometimes to just get the environment up and going. And so it takes a lot of time, a lot of investment to even get the infrastructure for running containers up in a development and a production environment. So what we wanted to do with the framework is look for ways to simplify and streamline that for the end user, so that not only is it easier to install the base components, which we'll talk about in just a moment, but it's also easy to integrate with other components that are part of that CNCF foundation of DevOps tools that are emerging in the market today. And so again, some of the focus for our framework involved streamlining not just installation but also updates and upgrades. If you can imagine, if it's difficult to set up the initial environment, it's equally been difficult to maintain that environment. So what we can do with the framework is help map all of these dependencies together so that we can create tools that make it easier to move components forward, either individually or together. The other thing that we really wanted to make sure with the framework that we were adhering to is the open standards that are being defined by the Linux Foundation under the CNCF project, and also the Open Container, the OCI initiative. So again, we wanted to keep it simple, and we wanted to make sure that we could expand. So we've built this framework with the intention that we've started in an iterative way with a foundation of components that are necessary for creating your orchestration layer. But then we want to make sure that we can also iterate, because these technologies are still evolving upstream in the community. And we want to make sure that we can take advantage of all of that innovation that continues to happen. And last but not least, we're trying to build this with the user in mind. So we are trying to think about our users and what do they need to spend their days on. And I think the complication of these environments is not the best use of some of our users' skills and abilities. Instead, they should be, using these environments to deliver their next generation apps and to support their end users in those goals. So again, we're building this tool with the end user in mind to try and reduce complexity and minimize risk. So I don't know how many people are following the CNCF, the cloud native landscape, if you will. A couple years ago, this was a smaller subset of projects. And each year it just grows exponentially. If you can see, it doesn't even really fit well on a slide anymore. And so I put this here just so people can kind of get a sense for, the number of components and the number of community projects that are being driven in this DevOps model. And each one of them delivers something slightly different. And all of them are dependent on the core framework, which is Kubernetes. And so a lot of this is, just, as you see, and if you follow the innovators curve, a lot of things are in this, the lead up on the bell curve. And it's very complicated for users who want to get this environment off and going. And so again, what we wanted to do is make sure that while you're faced with endless choices, we're picking some of what we consider or what we've experienced to be some of the more stable projects to deliver some of the features that were asked for the most. And as part of that, we're building that into the framework so that when you want to integrate something like monitoring with Prometheus, with extensions with Grafana, that it's easily pulled into the framework, and you don't have to figure out how do I get those things into the cluster. Instead, the framework is going to help manage that for you. So again, we're looking at the complexity of what's happening upstream in the community, and we're trying to take a commercial approach to that by saying, what are the core pieces that would be essential for end users? How can we build that into the framework? But also keeping the standard open, even if we don't deliver one of these given solutions within our own stack, you can easily integrate it into the framework either way. So we're going to talk about that a little bit later when we go through the demo. So here's kind of a summary of what we're attacking with the Oracle Linux Cloud Native environment as the beginning. So over on the left, you'll see Kubernetes. So for us, the framework is an open API library. We'll talk about that in just a minute, but everything starts with Kubernetes and the runtime environments that we can support within the cluster. And so for us, we've got two choices within our environment. We support the Run C, which is a lightweight runtime, and used with a number of products today, such as Docker. We've also added Kata. And for those of you who aren't familiar with Kata containers is really an additional layer of security for users who potentially have a specific workload that they want to deploy as a container, but they want some additional parameters around that for security purposes. So Kata effectively wraps the container in a small virtual machine, but it allows you to deploy in the Kubernetes cluster. The Kubernetes cluster is not aware that what it's deploying is anything other than a container. And so it provides an additional layer of security for some of our customers who've expressed a desire to use containers but are hesitant to do so because of the sensitive nature of what they're running in that environment. And so again, that's kind of the foundation of what you see over here on the left-hand side of the screen. The framework sits in the middle, and we're going to talk about the API library and what that means in just a moment. And then from that previous chart, you have a number of different choices for service mesh, for logging, for monitoring, for tracing, and eventually even CI/CD integration. So all of these things are targets for us with the Oracle Linux Cloud Native environment, and all of these things will be pulled in using the framework that we've developed. So Istio for service mesh, Prometheus and Grafana for monitoring, FluentD and Jaeger for tracing. And the final component that we'll bring in sometime in the future will be Jenkins X, which will provide that full lifecycle management for end users if you don't already have something in place today. And so this is kind of the target that we're hitting now. As we go forward in time, we may pull more in, but in terms of what we're initially targeting, these are the core components that we want to deliver. So when I talk about the framework, what I'm talking about at the core is an API server. So as I've mentioned, we're very focused on providing open standards that allow for not only the integration of the components that we want to deliver, but also other components that are part of the CNCF landscape, or even potentially at some point in the future, end user or customer modules that may be developed in-house. So again, we have a very small agent that will operate on each node, and it does not do anything other than execute requests on behalf of the API server. So we don't do pulls or polling, anything like that. It's simply there to provide some interface for the API server to take action on the nodes that are in the cluster. And so again, the combination of the agent and the API server is really what provides the groundwork, not only for just the installation, but configuration of the different components, updates of those components, or even upgrading to new versions of a component. And the thing that we're super proud about right now is this framework is being developed and will be an open source project that we're contributing to the community. So we're in the process right now of actually making this available on GitHub for those who are interested. And so for us, it's like I mentioned, we want to make sure that this is a community project driven by standards and also participating within the CNCF landscape. And when we go through the demo in a few moments, Dan is going to walk you through each one of these components and kind of describe for you how that works and how each one kind of interacts with the other. So one of the core pieces, so we have two ways of integrating with projects. We can either create what we call the module manifest, or we can actually integrate with community operators. They're called Kubernetes operators. So whether that module is Kubernetes as the core, which we used a manifest to put down Kubernetes as a cluster, or Istio, which we're working on right now for service mesh. The manifest is a representation of the module itself. It maps the metadata that is necessary to install, configure, and manage that particular component. So again, it can help us identify any prerequisites that are needed. So if Istio 1.3 requires Kubernetes 1.13 or later, we can map that in through the manifest. It can help us isolate and determine any dependent properties, like it needs authorization to different services or components. It can help us with the general configuration, so any kind of profiles that are associated with a given component. And it can also help us set the environment variables, so letting us know if a particular component needs to have access to a master node or a worker node is an example. So everything that we do within the module manifest helps us kind of create the metadata that lets the API server understand how that component works, and not only how it works as an individual component, but how it works in conjunction with other components. So again, I think I just covered this in detail, but what will happen after we map and create the metadata that becomes the template for the API server, then what the API server will do is it will compare that manifest to the actual state. It will decide what the delta is between the two, and then it can take action by converting into a script, which can then be executed by the agent on the node to do what is necessary to either lay down a component, update a component, change the configuration on a component, etc. And as I mentioned, we have two ways of mapping components into the framework. We can use our module manifest, which I just described, but also Kubernetes has been working within the community space on these concepts called operators. They're also wrapped with their own lifecycle management tools, and it's another way that we can integrate CNCF modules into the framework. So again, this is a project that's developed and maintained at the community level by different companies and participants. So again, it's a simplified way to insert some of these components into the Kubernetes cluster. And so there will be instances where we find that we have a stable operator already available in the upstream community. We may choose to use that operator natively, versus other times where there's some complexity within a specific component and we don't feel that the operator is mapping to that complexity in the way that we would like. So we might put that in as a manifest module at first as we develop an operator that can be replaced, that can replace the manifest later. So again, it just provides us more flexibility within the framework itself for integrating different components into the cluster and into the orchestration service. Well, with that, I think I don't want to spend all the time talking because I know Dan's got some demos that are pretty interesting and I want to get that going here. So I'm going to go ahead and stop the share on my side. I'm going to hand control over to Dan, who's going to pick this up and walk you through a demo. And as I mentioned, we are monitoring the chat screen, but also as Dan goes through the demo, when he's going through certain activities, it may take a minute for those pieces to execute, and he'll stop for Q&A at that point as well, and you can go ahead and unmute yourself and ask your questions. So Dan, I'm going to go ahead and turn this over to you now.
Thank you, Michelle. I'm going to share my screen, and you'll have to excuse the full desktop share, but I have to bounce between windows. And I suppose I promised some video, huh? So let's do that. Okay. So like Michelle said, I'm going to go through several aspects of OLCNE and show how they all fit together. I have two discrete segments to this. The first is we're going to be installing a Kubernetes cluster with a single master and single worker from scratch. So these two windows represent fresh machines. The only thing that I did to them was set up SSH keys so that I could SSH between them without a password. But other than that, this is a vanilla Oracle Linux 7.7 installation. This window is going to represent a worker node. This window is going to represent a Kubernetes master node. The second half is I have put together a pre-canned cluster that has 3 master nodes configured in a true high availability setup. And we'll walk through the details of that then. It's also a good place to show off how easy it is to switch a container that you're deploying from a runC-based container to a Kata-based container, because those systems have nested virtualization enabled and these VMs here don't. So we're going to have to use that. So that being said, let's get started. So the first thing to do is we need to install the agent on any node that is going to be running anything that is installed by the cloud native environment. So your API server can live anywhere. It can live on one of your worker or master nodes. It can live on a third persistent node somewhere in your infrastructure. It can live on your desktop, quite frankly. Whatever works for your deployment. To keep the number of VMs down, I'm going to put the API server on the Kubernetes master node just for simplicity. So the first step in that is installing some packages. No, that's not. The first step is enabling the repos. So we're going to look at this. We have to enable 3 from a default install. So we need kvm utils. That brings in several of the components needed to support Kata-based containers. We need OL7_OLCNE, which brings in the core cloud native environment packages. And finally, we need add-ons. Just for some extra doodads here and there. Okay, next we install some packages. So this system already has an agent installed just for simplicity's sake, but we're going to install the full setup here. Sorry, it's early yet. So the API server represents the API server and all of its components. Dash agent is the agent. OLCNE CTL is the CLI utility that talks to the API server for most interactions. And then finally, we have a utils package that just, it has some helper scripts that are useful in certain circumstances. I think they're probably more appropriate for demos and development environments than they are for actual production deployments, but the tooling is there. I misspelled something, apologies. So this is probably a good minute for a question or two if someone has one.
And remember, your lines are on mute, so if you want to ask a question, just unmute yourself on Zoom, or if you want to post it in the chat channel, we can also just read from the chat channel and answer it there. So while we're waiting for this to go through, and we didn't get any questions, but there was a question earlier in the chat about Oracle's, how much Oracle is participating in the upstream projects, the CNCF and others. And so, you know, again, Oracle has been an active participant in the Linux Foundation for years. In fact, you know, we've sponsored the Linux Foundation for years. And by extension, we do sponsor the community projects involving CNCF as well. So we do have representation in those things. I think the thing that's interesting here with what we're describing today is, you know, we do want this to be part of the community landscape. And so we are going to, as I mentioned, open source this particular framework that Daniel is showing us today and that the development team has worked so hard to get off the ground. We're going to put that on GitHub. And the focus of this would really ultimately be so that we can submit this to CNCF as a tool that could be used across, you know, the community landscape. So we do actively participate in these communities, and we're working to improve the solutions, including contributing some of our own work like you're seeing here today.
Okay. So now that we have all that installed, the next step is we have to get authentication set up between all the players. The stance that we've taken from a design point of view is that we want to make sure that it is very easy to set up, very, you know, regimented security boundaries in between various elements of the system. And we want to make sure that customers who are the most paranoid are able to put together an environment that they're comfortable with. Conversely, we don't want to force people to maintain that level of discipline if it doesn't apply to their environment. If it's sufficient, you know, for a particular use case to have a more lax setup, we want to make sure that that's available as well. So we take a fairly lightweight stance on how certificates are put together. We do no additional verification other than the PKI system would normally impose. But we do very strictly enforce the best practices around generally enforcing that. So, for example, when doing verification on communication, we do it bidirectionally. So when the API server communicates to an agent, they will both authenticate each other, and they will strictly authenticate each other and ensure that their certificates actually apply, and they are who they say they are, before allowing any action to occur. Now, the way that those certificates are configured is pretty fungible, and you can kind of do whatever you feel like there, as long as it fits the standard of making sure that that strict TLS style security is in place. So we're going to generate some real fast. They're going to be pretty fake, but it'll get the job done. Let me get my IP address list up here. Okay, so we bundled a little utility in OLC&E utils. Again, this is not really, it's not a production grade certificate generation solution. This is more about demonstrating what's available and how one would go about doing this. So we do that, and we need some nodes, which are these. No, it's not, it's these. So we need this one, we need the other window. And this should make us this is going to generate for us a CA. And that is going to create CSRs and signatures for a certificate for 10.0.114 and 10.0.114 and 10.0.113.
And Dan, correct me if I'm wrong, but I think we're also working on a developer paper about, examples of how to integrate with something like Vault or something else. So we don't provide the certificate authorities, we don't manage certificate stores, but we will provide some, white papers, tech docs that kind of talk about examples of using some of these tools, if I'm not mistaken.
Yes, yeah. And that actually raises a really good point that I forgot to bring up, which is that we do have a certain level of integration with Vault built in to the cloud native environment tools. So each tool is capable of accepting a Vault token and provisioning its own certificates using Vault APIs to talk to some centralized Vault and pull those certificates down and then manage the lifecycle of them locally. So if you have a Vault instance, it's very easy to handle that integration because you just give us a token and we will kind of handle the rest for you. And other white papers are forthcoming about how to set this up in a more robust way. So this tool puts together a CA and a certificate. So if we bounce here into configs and certs, we have under production, there is some CA information. And then under temp OLC&E, there will be directories for the specific files for each node. It also generates this transfer script that you can see right here, but my environment diverges very hard from best practices on SSH, so that one just doesn't work for us right now. So the next step is to get these onto the individual nodes into the right place. This is configurable. You can put your certificates anywhere, but by default, they go into etc OLC&E certificates. So we're going to copy them to that location on this host, and then we're going to copy them over to the other window and move them. So we go like this, and those all go to, okay. And then we're going to do the same thing, except with SCP, and it's going to go over to our other node here. we have certificates. So now that the certificates are available, we can start the services for the OLC and the agent and the OLC and the API server. They will refuse to start if the certificates are not in place and cannot be validated. And that is mostly to make sure that you don't accidentally end up with an insecure setup. So we're going to bring this up real quick, and hopefully it starts, but I might have made a mistake in the copy, so we'll see. Perfect. Okay, then we're going to do the same over here. Bring those up, just give them a second to start. Looks good. Cool. Okay, so now we have the base daemon set up to interact with everything. So then we're going to use the CLI to talk to the API server and actually get all the environment created and up and running. So the first step in that process is we need certificates for the CLI. There are different ways to configure this. I don't want to go into all of them now, but there's features in place that make it easy to deal with a single environment, and there are features that allow it, that facilitate using a much broader setup that talks to different API servers and whatnot, and it's not worth getting into here, but they're there. So we're going to take the easy way out. I think it's node cert. Smarter person would have written all this down ahead of time. I need the private key. There are also features in place to do per user certificates rather than node level certificates, which I'm just trying to keep things simple from a demo point of view. Okay, so now we have everything set up for it occurs to me I didn't actually have to do these exports because this will pick up the defaults, but here we are. So the first thing we need is the API server address. Traditionally, this runs on port 8091. The reason I'm using an IP address here rather than localhost or something is just because there's less weirdness going on with authentication certificates. So I have found it easier in practice to use public IP addresses. Okay. So what we have to do first is we have to create an environment, and an environment inside the cloud native environment is a container. It's a virtual container that just holds other installable things together into a bundle. So it doesn't really have any semantics associated with it, but for namespacing various Kubernetes clusters and other components, we wanted to have this here just to make people's lives easier. And so we're going to call it ACE demo. See, I picked the wrong thing. Okay, let me, sorry, I forgot what this was named offhand. I just need 2 seconds. Right, okay. So it is CA path. See, I know what I'm talking about. It is key path. And cert path, which make a lot more sense than what I typed. insert path, key path, boom. Okay. Cool. So now we have the ACE demo environment created. Inside environments, modules can be created, destroyed, installed, etc. The first step of our workflow is to create a module inside that environment. And that basically, it pushes all the config to the API server, but it doesn't try to install anything yet. And there's a number of lifecycle reasons for doing that. We're going to install Kubernetes, and we're going to call it test. Okay, so I'm going to provide this information. Other arguments are mandatory to put this cluster together. We need to know what our nodes look like. We need to know where certain paths are. So you can provide those as command line arguments, or you can allow the CLI to prompt you, like so. So we put that in place. We're going to put in our master node IP address, and it occurs to me that this is not going to ask me for a worker node, so I'm going to destroy this and make one that has an explicit worker node. So yeah, that in, and that makes the module. So what's interesting about the way this is set up is that this conversation about what's required and how to fill it out, those rules are actually generated by the API server at runtime and pushed to whatever the client is when it's contextually relevant. So this rich semantic around querying for certain arguments and other stuff is available regardless of what client is connecting and how it's implemented. Okay, the astute among you will also realize that it does mean that the CLI is dependent on the API server to be able to parse its own arguments. Okay, so we need a worker. Okay, cool. The next step in this process is ensuring that we are capable of actually installing Kubernetes, right? There are a number of security sensitive details that might have to be changed for Kubernetes to run successfully in an environment, firewall ports, SE Linux, etc. So we wanted to make sure that we could communicate that and verify it and be useful, but we also didn't necessarily feel comfortable just opening up ports under the scenes without making it very clear that it needed to happen and that what exactly was going to go. So the validate subcommand goes through and checks all of these rules that are in place and ensures that they are true. And if any of those rules fail, we will print out some data on what to do about it. So you can see here, like, again, these are bare nodes. We don't have Kubernetes installed. We don't have kernel modules in place. We don't have a ton of other stuff that needs to be there. So the script gets generated to tell you, what you can do about it. We also provided the -g argument, and what that does is it actually generates scripts. So if we look at this, we get a script per node that tells us exactly what needs to happen on that node in order to make everything validate correctly. So these take a little bit because they install a bunch of stuff. I'm gonna kick off the first one and we can do some questions, and I'll kick off the second one, and when that's done, we'll get back. that's true. Let me pull up my chat window here. I'm sorry. Okay, nothing super important going on there. Okay, so you know, as Michele brought up when she was going through the slides, there's a graph of all of the components and how they fit together and what all the various pieces mean to one another. And the scripts that tell the system or the operator, depending on what the context is, how to do those things is generated out of that graph. And so it leads to some surprising behaviors sometimes. So for example, you might have noticed that the two scripts, even though they told you to execute the same commands, were in fact in different orders. And the order is always correct on a dependency basis. So it will not tell you to start a service before it has told you to install the package for that service, for example. But it might tell you to start service A before service B or B before A, you know, depending on what the graph traversal looks like. And that throws people sometimes, but ultimately it's all the same stuff. Okay, so we're gonna do the same thing here locally. I'm gonna keep the SSH invocation even though it's local because I'm too lazy to do anything about it. Okay, and after this is done, I'm gonna run validate again, and you will see that the set of things to do is empty now, or at least it should be. That same process is invoked in front of every operation that modifies the system somehow to ensure that if OLCNE is going to do something, that it's very likely to succeed. You know, we wanted to prevent situations where you get a half an hour into something and then it fails because some esoteric system setting that nobody knew about wasn't set correctly. So we put a lot of work into making sure that that wouldn't happen. We'll just let this keep going for a bit. As the environment matures, more and more of the commands that were part of that script are going to get pushed into the agent itself. You know, just as we become comfortable with how they're implemented and make sure that they're not going to damage anything. So over time, you know, that list of actions to take will get reduced to the minimum that we're comfortable with doing. The minimum set of things that need to be done that we don't feel comfortable doing on the behalf of someone. Cool. So now we have those packages installed. And if I go through all my typos here, we'll get back up to validate. And I'm going to take off the -G just because I'm confident. Why is that happening? Well, this is curious. I have not seen this before. I don't know what's going on here. Obviously, it's asking me to install kernel 3.10.0, which doesn't make a tremendous amount of sense. These are the demo gods coming out to get us. I've run this code 100 times. I've never seen that before. So I don't think I can debug this in the next 10 minutes. So I'm just going to skip this. I was going to replace the word validate with install, and then there was going to be Kubernetes in 5 minutes. So, but I have a Kubernetes floating over here in this window. So we're going to use that, and we are going to finish off the kata and runc portion of this demo, and I will go and take a look at that and fix it. So yeah, sorry about that. Okay, so as I said, I have a cluster running here using the exact same code that was running on those systems, and it came up successfully. So there's that. Okay, so we have 3 masters and 2 workers here. I'm going to SSH over to one of the masters so that we can take a look at some of the architecture of the high availability deployment that we put together, because I think it's pretty slick. So obviously in a in a lot of environments, you're going to want to be using an external load balancer and failover setup to do high availability Kubernetes. And that option is available to you via one of the installation arguments for the Kubernetes module. But not everybody has that, and they still want to do high availability Kubernetes, which is understandable. Because if your master node goes down, you are in for a bad time. So want to make sure that there's some redundancy there. So we've put together a pre-baked high availability setup that only requires 1 extra argument to the installer and 0 extra hardware. And that is done via an instance of keepalive, which you can see here, managing a virtual IP address running on each of the master nodes. So if a master node goes down, or the processes that are running Kubernetes go down, that keepalive instance can lose its mastership, and another keepalive can pick up the virtual IP that we're bouncing around to make sure that the machine is always accessible. The other portion of this is that each system is running Nginx configured as a load balancer to each of the other master nodes. So not only is there an active setup making sure that the IP address that is the target of your cluster is always available, but behind that is a load balancer that is ensuring not only that the traffic between all of your masters is balanced, it's ensuring that if one of the master nodes goes down, that the other 2 are being talked to instead. And the net result is a very robust setup. And then we have the cluster stuff here, so exciting. Bring in our nodes again. One of the facilities that OLCNE has that we haven't touched on yet is that elements of the configuration can be grabbed out of the modules when they're installed and reused elsewhere. So one of the important things that artifacts of a Kubernetes installation is the kube config that lets you talk to the cluster. So we have a subcommand, module property get, that lets you just go get the kube config from whatever cluster based on the name that you installed it at. That facility is going to get expanded on as other modules come into existence so that we can express configuration dependencies between various nodes. And we can say things like, if I want to install, for example, like Helm, just to pick one, Helm can grab the kube config from the Kubernetes module and auto configure itself to talk to the right cluster in the right way. And you don't have to worry about duplicating bits of spurious config between various elements of the system. So that's something that we're investing a lot into right now. Anyway, let's talk about Kata. So as Michele mentioned, we have 2 different runtimes available. We have runc and we have Kata. Runc is your traditional Docker container, everything's in the C group, yada, yada. Kata decides to put everything inside of a virtual machine so that you have some better isolation and protecting your various resources from one another. So we have a basic pod definition. It deploys Nginx. You can poke at it from a service at one of these IP addresses, kind of based on wherever the service lands. I didn't go and set up actual ingress into this cluster. So this is what we're stuck with. But we're going to deploy a runc version of it now. So that's going to go. We're going to give it a minute to pull the images, and probably should make sure that's going right. Yeah. So I'm going to give that a second, make sure that it actually boogies. and then we'll go from there. So back to the Kata versus runc distinction. Kubernetes 1.14 completely overhauled the way that it handles runtimes. That the first bit of code was introduced into 1.12 behind an alpha feature gate. Now it's not only like it's been promoted to beta, but the old facility is dead. But the new one's a lot slicker. So you can define on each of your worker and master nodes a set of runtimes that it is capable of supporting, and configuring that on each instance to talk to the right binaries and use the right features. Cool. From there, you can select them with just a flip of a switch. So we'll get to that in a second. First, I want to prove that this Nginx is actually running. So we are going to do a get pods-o wide. Okay, we're on 4, so I want 97. 236.97. Oh, I need to do sorry, I forgot one thing. There we go. Okay. So we're going to curl that real quick. What did we say it was? We said it was 97:31530. So this is just, I didn't pick a port, so I let Kubernetes assign one randomly. Hey, we have Nginx. Okay. But if we go SSH to this box, when we take a look at the process tree, we will see that we have this Nginx process running under cryo. Okay, that's great. But let's pretend that we're super worried that somebody is going to compromise our Echo server and then take over this box, and we're not comfortable running this, this close to the host. Because even though this is inside of a C group, there's ways, it's in principle possible to break out of a C group by exploiting bugs in the kernel. And so we'd like that extra bit of protection. So we're going to delete it. We're going to edit this file again. And now we're going to tell it to run this in Kata. So we just uncomment container class or runtime class name Kata. And that should have shaken out by now. So we'll go. We'll let that go. It should start up pretty fast because it should get scheduled to the same node and we shouldn't have to pull the images again, but we'll make sure, yep, we're golden. And so we bop over here. And now we see the telltale signs of a Kata container, which is to say the Kata controller processes, and then notably the QEMU, which is the actual VM that represents the container that's being run. It's worth noting that when these VMs are put together, they're built on pods, not on containers. So if you have a pod with a bunch of containers, you can have several containers inside of a single VM. So you can control what your abstraction boundary is and your isolation boundary between various containers and virtual machines, depending on what you're comfortable with and what your needs are. So that's all available by fussing with that a little bit. Anyway, so that's floating there. We have a new service, so we have a new port number, but we can ping this again. And we should get the same Nginx welcome screen, even though it's coming from inside a VM now rather than from a C group based container on the system. And so with that, it is 11 o'clock. That's all the material that I had to cover minus the snafu earlier. So yeah, but I hope that was informative.
Thanks, Dan. And just to close this out, so we will share the slides. I do want to let people know we did have a question about whether Oracle Linux Cloud Native Environment is production today, and the things that Dan was just showcasing are available for production support as part of Oracle Linux. And we are working on the inclusion of features like the service mesh with Istio, as well as logging and visualization with tools like Prometheus. So we will continue to provide updates as those components get integrated in. We appreciate your time today again. We will send out the deck. If you do have additional questions, please let Jennifer know. And again, happy holidays to those in the US, and thank you again for your time today.
Thank you, everyone.
Thanks, everyone.